Welcome back to yet another Moralis video. In this video, I'll be showing you how you can stream live blockchain data right into your data warehouse. We're going to be covering both how you can do it in real time, so that for every block, we're going to be streaming exactly the data you want into your database, and how you can also backfill your database. So if you need to build up a data warehouse with, for example, what we'll use in this video will be ERC20 transfers of USDT. Let's say you want a database full of all transfers of USDT. In this video, I'll show you how to backfill that to whenever you need, and make sure that for every block that comes in, you'll be syncing, streaming these new transfers straight into your data warehouse. And the end result, what we'll be able to do, it of course depends on your use case. But in this case, I'm just doing a quick analytics dashboard in Looker Studio, and it will look something like this. So here I have a table with the top receivers of USDT transfers. You have the chart of total transfer volumes in USD or in USDT, should be the same. And down here you have some stats, number of transfers, unique senders, median transfer value, average transfer value, and the total volume for the period, which you can select up here. We can do last 7 days, apply, and it will change around the chart. It will change around all the values. And behind this is a massive table of USDT transfers in BigQuery. So that's what I'll be using for this video, but it will be super easy to replicate with any other data warehouse that you might be using. So here I'm just querying all of the columns from my ERC20 transfers table. I'm ordering by block number descending, and you'll be seeing all of the transfers here. And as you can see, they are in real time. The latest block number I have here ends in 404. And this was today, April 25, this was 10 minutes ago. So if I run this again, and we check the latest block number, it will not be, was it 404? Now it's 453. And this will continue to update for every new block that there is. And you can see here that it's Tether USD. You can see the decimals, you can see the value of the transfers, the from, the to, the contract, the transaction hash, you can see the chain, you can see the log index, and the timestamp. And I'll show you exactly how to set this up from start to finish, and you'll be able to also sync data straight into your data warehouse. If that's for doing a reporting dashboard, some analytics use case, that will be up to you. I'll show you how I created this in a very simple way. But you can use data in a data warehouse for anything. So if you need data like transfers, or even if you need NFT transfers or just block data, regular transactions, mints, burns, any type of custom event, this tutorial will show you how to do it. I'm just using USD transfers as an example. The Moralis streaming tool that we're going to use today, Moralis Streams, allows you to stream for any custom event. So you can really figure out exactly what data you need, set up the stream, and stream it straight into your database. It's super easy. Let's get started. And we'll get started here in the Google Cloud console, and specifically in the BigQuery, what do you call it, product. If you want to find it, you can just put BigQuery here and go here. The first time you might need to actually enable the product. You'll get queried on like, okay, you need to enable this in your account, and of course need to set up your billing and so on. But I assume that you already have that going. And when we have that, we're going to create our first data set here. And you'll need a project set up. I have this Moralis YouTube video project, which is empty. And then in BigQuery here, you want to create data set. And we're going to name this something. So we could name this like on-chain analysis or whatever. Oh, okay, let's just call it analysis then. We cannot have any dash, multi-region, create data set. If the region matters to you, you can of course set the region. It doesn't really matter for me for this project. And then we have this analysis data set here, and inside of there we want to create a table, and this is the table where we will store all of our transfer data. Create table from empty table. Project is Moralis YouTube video, data set is analysis, table name. This can be transfers, because in here we'll store ERC20 transfers, and it will be a native table. Then the schema Oh, sorry, not add it as text. We're going to add the schema here with all of the fields that we need. And the first one we'll have is transaction hash. And there's going to be a string. And then we're going to add contract, which will be the contract address. That will also be a string. Then we'll have from and to. All of these are also string. This will be the from address and the to address of the transfer. And then we will have the value of the transfer. And this will be the amount of tokens that we send. And the type here, it needs to be big numeric, because some tokens will have 18 decimals. And that means that if you transfer a really large amount, like 1 million tokens of something with 18 decimals, then there will be a lot of zeros at the end there, or not necessarily zeros, but a lot of numbers. So we need that big numeric type. And then we're going to have decimals. And this will just be an integer. So this will signal how many decimals, like 2 decimals, 3 decimals, 4 decimals, etc. And that's how we'll use that in order to get to the actual like real value from, well, you see this later, but if you're familiar with transfers in Ethereum or EVM chains, the value field contains the transfer value, but without any decimal point. And you'll need to use the decimals number in order to place the decimal point in the right place. After decimals field, we'll add a symbol field. So this will be the symbol of the token if you want to add multiple tokens to the same table in the future. We'll have the, and the symbol is going to be a string, yes. Then we'll have token name. And we'll have a field that's called triggered by. I'm not sure we're going to use this, but it comes with our, or let's see, it comes with our stream. Well, in this case, we're not really going to need it because we'll also backfill this database. We'll actually skip that one. And we'll just do block number instead. And this will help us identify, obviously, where in time this transfer happened. That's also going to be a string, but does it need to be? We'll leave it as string for now, because I don't think we'll do any like math operation with the block number. We're going to have the chain, which will be a string. And then we'll have a timestamp. We'll call it timestamp, and that's going to be type timestamp also. So this will be the block time when this transfer was made. We'll also have a log index field, which we can leave as string. And this will help us identify unique transfers within a single transaction, because the transaction hash, the actual transaction can contain many transfers in one transaction. So if we want to identify a single transfer in order so that we don't have duplicates and so on, we need the transaction hash as well as the log index in order to identify the specific transfer within the transaction. And the log index contains that. That is the order in which it appears in the transaction. That is it for the table. We need no partitioning, we need no tags. So we're going to hit create table. And now you'll see our transfer table here on the left, and it will contain all of our different types like so. If you need any other parameters, you can of course add that in, but this will be basically what we'll be getting from the API. We can also include, should we do that? Well, let's include it actually, because it's easier now before we have any data. So we'll add from label, which is a string, and to label. So if Moralis, because we store labels for addresses, so if it's like a Binance, a known Binance address, or a known Coinbase address, known something else, Uniswap address, we have those labels in the API, so we can actually leverage those to make it maybe a bit more recognizable. I'm not sure we're going to use it, but why not add it? We don't have it for all addresses, obviously, but when there is a label, we can add it. And now that we have this, we can go ahead and create or start to create our cloud function, which will be used to take a webhook from the Moralis stream and input it into this table. So I'll go up here and search again for cloud function, cloud functions. There it is. This might also be something that the first time you get here, you need to enable it. But once you have enabled it, it should look something like this. And then we can go ahead and create our function. And here you can see that in this project, I don't have all of these APIs enabled. So I'm going to need to hit enable before I proceed. And now we get to configure the basics here. Environment is going to be 2nd gen. That's the latest, as at least as of recording this. Function name can be insert ERC20 transfers. Region US Central. Trigger type is going to be HTTPS because that's the webhook type. We are going to allow unauthenticated invocations. I'll show you later how you can actually authorize in the function itself to make sure that you're not inserting data into the database that is not coming from Moralis. Then we're going to hit next. And we can also see here that we have Cloud Run Admin API not enabled. So we're going to enable that. There we go. And now we get this basic function, what would you call it, boilerplate here in BigQuery. Let me zoom in here a bit. There we go. And here's where we can build our function. And you can build this locally using your editor as well. But for this short little thing, we're going to be just in the editor here. And because we're working with BigQuery, we're going to need to add that to our package.json. And we're going to add the same as the above at Google Cloud /BigQuery. And at least as of today, the latest version is 7.5.1. So we're going to add that into our dependency. But you can, of course, check on the NPM website what the latest Google Cloud BigQuery package is if you want to use that. But if you want to use the same version as I am, 7.5.1 is the latest. And then we'll go into the index.js. The first thing we need to do is to import our Google Cloud BigQuery library or package. And we'll do that here. Const BigQuery is equal to require, and we'll use this npm string here, like so. And then we're also going to initialize BigQuery here, new BigQuery, and in here we'll pass in an object, and this will be our project ID, and our project ID will have to we'll open up a new tab and go back to our BigQuery project. Go back to BigQuery. Okay, so the ID is just the name. And then we'll start building our function here. This is what will actually be called. We'll rename this to insert ERC20 transfers. And we'll also have to remember to change this entry point up here to the same insert ERC20 transfer, otherwise there will be no function to test once we test this. And now that we've done the initial setup here, we're going to jump over to Moralis to define our actual stream and the webhook so that we can get the format of the webhook and then start to build this function out. So head over to moralis.io, hit login. And once you're signed in to Moralis, you're going to hit on Streams. And then you're going to click on Create New Stream. Select the EVM stream. And then you'll get guided through the streams setup here. And you can also set this up through the API. If you're interested in that, you can go to docs.moralis.io and go to Streams API. And here you can get the documentation for setting up, including tutorials for how to set up the stream using the API. But for now, we'll do it through the user interface. What types of events do you want to track? We want to track contract events because we're going to track transfers. So we'll click on contract events, click on continue, and then which type of contract events do you want to track? We'll click on common events here and select token transfers, then hit continue. What additional data should be included in your webhook? For now, this is mandatory, this stream tag. It won't be in the future, so you might not have to fill this out, but we'll put this as ERC20 transfers. Then you get asked if you also want to include related transactions and transaction logs for the actual transfers. We do not need that, so we're going to skip that. Then, which addresses do you want to track? And here we want to add all of the contract addresses that we want to monitor. And we're therefore going to find the USDT contract on Ethereum, which is here. And we can take the contract address either from the URL bar or from, let's see, we'll go to token tracker. Oh wait, I have the address up there. here, token contract. Copy the address, go back to Moralis, and we'll paste that address in here, add address. Then we'll hit continue. For chains, it will just be Ethereum. For this one, you can of course add as many chains as you want. Make sure you add those addresses if that's the case. Hit continue. And now we can test this stream response. So we'll select the chain, Ethereum mainnet. It needs to be the same chain as the contract is on, obviously. And then we'll select the latest block where we have some kind of confirmed transfer. So this would be this one, I guess. We'll copy that block number and paste that here, and then click test stream. And then we'll get a response here, which will be an example, an exact replica of what would have been sent to your webhook if this was a live block, okay? And what we'll see here is that we get a bunch of logs. And what we're interested in is in ERC20 transfers. So here we'll get all of the transfers that were USDT transfers in this block, okay? And this is what we're going to be inserting into our BigQuery database once we get the webhook. But what I'm interested in here is using this to build out our webhook, because here I know what the body will look like of the request. So I can use this in order to build out the code in the Cloud function. So here is where I'll have all of this, decimal, symbol, and name, value, and so on. And I can, if I want, actually, you can find this as a pure JSON object. For now, you cannot copy it from here. I would like the team to insert the button here where you can copy the JSON. But you can find the JSON if you go to network and you click on test stream and you find the request here. And you should be able to find the JSON response. Yes, here. So you can copy this if you want. If you want to develop using this JSON, you can do that. But for now, we know the response structure. So now we can go ahead and go back into our function code and start to create this function so that it takes the webhook, it parses the data, and for each transfer, it inserts it into the BigQuery table. And the first thing that we're going to do is going to remove this hello world result send and start by wrapping everything inside a try catch. Because we're going to be working with inserting into a database, we're going to need to catch any errors that might come up from this. And then within this try block, that's where we're going to do most of our things. And first of all, we're going to define our dataset ID, where we'll be inserting the data. We call this analysis. And we called our table name or table ID, we call that transfers. And then after this, we can start extracting the data from the request webhook. And we'll get the body of this with request.body. And then we'll create an array called transfers. And this is where we'll store all of the ERC20 transfers of this block. And then we can take this entire array of transfers and insert that into the database. So now we'll just have to loop through all of the transfers in the body and format it to an object that we want and add it into the transfers array. So where do we find the transfers? In body.erc20 transfers. As we saw in our Moralis block here, we have the root, and in here we have the ERC20 transfers. So this array is what we want to tap into. Body.erc20 transfers .for each. So for each transfer, we want to run a function where we'll transform this and add into the transfers array. First of all, we need to get the date and convert that into a timestamp that we can use in BigQuery. So we're going to extract the date, and we'll use the JavaScript date object for that. And in here, we're going to parse an integer from body.block.timestamp, which once again we can find inside here. So body block, you can see the timestamp is this Unix timestamp, okay? We're going to use that, but multiply it with 1,000 because BigQuery expects it to be in milliseconds, whereas Moralis, we send it in seconds. So we're gonna use parse int here, and let's see, let's keep track of my parentheses. Well, that looks correct. We're also gonna input, just for being on the safe side, a second argument here to parse int, which is the radix, which is the numerical system that we're using here, which is base 10. I'm not sure, it should be base 10 by default, but it's not always, so we're gonna do that. And then all we need to do is to convert this date into a BigQuery or a string that BigQuery can interpret. BigQuery timestamp is going to be equal to date dot to ISO string, which is a standard date method to get this into a standardized string format, which will give you the date and the time in a single string. And when we have done that conversion, now what we need to do is to go through each of the transfers here and add it to our transfers array, which will then be inserted into our database, data warehouse. So we're going to push into the transfers array a new object where we'll take the transfer object from Moralis and just change the name so it conforms to the database that we created. And you could simplify this a bit if you chose the exact same names for the transfer, but it would still not really work because some of the data points, as you'll see, will come from the block data, for example. But we have our different parameters here that we specified in the table. Let's see. Close. Where do I have them? Here. All of these need to be added to this object. So we have transaction hash, we have contract, we have from, and I'm just typing out all of the properties that we're gonna need to add here. Value, I'm not filling them out. Decimals, symbol, token name. No, we didn't have triggered by, block number, chain, and timestamp. And then we also had these from label and to label, but I realized now when I was filming this that we don't actually have those in the Streams API yet. So we're gonna leave those as undefined for now. Maybe when you're taking this video, the labels of the addresses will be in the Streams response, but for now it is not, it's only in the API. So we'll fill these in. The transaction hash is gonna be transfer.transaction hash. And of course, now you can get these from the transfers here. So we'll minimize that. We'll go into transfers. And here you can see all of the values that we're gonna import into this new transfer object. So transfer.transaction hash, contract, we have transfer.contract. From, we have transfer.from, transfer.to, transfer.value, transfer.token decimals, transfer.token symbol, transfer.token name, and then for block number, we actually have body.block.number. So that would be body, block, and then number here. And then chain is also going to be body.chainID, and timestamp is going to be our BigQuery timestamp, like so. And now we do have everything we need in terms of adding the data to the array. We've translated everything over, mapped everything over. And so at the end of this for each, we've now created this array. So at the end of that, we can now add this array into our database. But before we do that, we're gonna check, first of all, so that this actually is an array. We're gonna do some error handling here or catch some exceptions. And we're gonna check if transfers actually is an array and that transfers.length is larger than 0. And if it is, and I'll explain why we do this in a second, but if it is an array and it has more than, it's not empty, then we'll call await BigQuery.dataset for our dataset ID, and then .table with our table ID. and insert, and we'll insert our transfers array. And because we have await here, we need to add async up here to our actual function. And after that, we can console log. We can say inserted transfers.length rows into data set or we'll just do the table into table ID. And then we need to send back a 200 response status. So result.status 200.send, and we'll just say data inserted successfully. And the reason that we're doing this check with this if statement is because if that's not true, we still want to send a successful response status. So we want to send status 200, but we want to send block contains no data, inserted no data. And that's because in a normal situation, Moralis would always send a webhook with data. It would never send an empty webhook. But when we initialize our webhook, it will send like a test webhook to test the response of the endpoint that we input into Moralis. And for that reason, we need to respond with a successful status even though the webhook is empty. So unless there has been an error with inserting the data, we should return a successful response. Now we come to, okay, so what if there's an error inserting or converting this data? Then we need to send back an error to Moralis so that Moralis knows that this webhook was not successfully processed, and it will flag it in Moralis as an unsuccessful delivery, and you can retry it later. And so that's what we have this catch statement for. So in here, we're gonna do first console.error. We're gonna do error while inserting into BigQuery for block. So this can help us for block. And this would then be body.block.number. And then we'll also pass in the actual error. And then we're also going to send a unsuccessful response status. So we'll send error 500 and we'll pass in the message. Doesn't really matter here, fail to insert into BigQuery. There we go. I think that is correct. Now, there's only one thing left to do, and that is to test it. So, I'll copy this just in case something goes wrong here. That's the worst thing about editing, in an online editor, that maybe you refresh the page or something and it's gone. So, I'm going to make sure we copy that, and maybe you can even paste it into a local file of yours so that you have it. Then we're going to test this function. We hit test and start testing. And for this, we're going to need to input the body here on the right. So we're going to go to Moralis once again. And now we're going to do what I showed you before. We're going to take this response body from the network thing, which is here, this response. We're going to copy that. If you can't find it here, clear the thing, click test stream for a specific block, and then grab this and take that. Paste that into this function here, boop. And now we're gonna try it and see if it inserts the data into our database. We have his journey transfers, we have the same name here, make sure you have the same name here, entry point, same name here, run test. Inserted 43 rows into table transfers. Data inserted successfully. Let's see. Let's look at our database. Let's query it. Select everything. Run. Boom. Transaction has contract from to value, decimals, USDT, tether, log index. Oh, I forgot about log index. Crap. Well, that's not too late. We can still add log index. From label will be null and to label will be null, but log index we should add. And then we're going to clear this database, by the way. So we start from a fresh state. So we're going to add to our transfers.push also log index. and that's going to be equal to transfer dot, I believe, just log index, like so, camel case. Let's check that. Transfers, where's transfers? Transfers, log index. Yep, good. Then this is ready to deploy. We'll deploy that, the function. Then we're going to clear our table, and then we can activate the webhook and watch the data come in. Creating function, boop, boop, boop. While that is deploying and building, we go back to our table, and we're going to, now I realize the thing, if we're going to copy this in an easy way, it's not, we cannot really keep the same name. So we're going to have to change the name on this, but never mind. Let's see here. Can we copy this table? We're going to make a copy of this. So we'll call this ERC20 transfers instead this table. Okay. We're going to make a copy of this because that's going to be an empty copy. So now I've got ERC20 transfers, and hopefully this is empty. Yes. Then we can drop our transfers table. We'll delete the old transfers table. And the reason I want to do this is because I don't want that test data in there. Now we got the empty table with the same schema, and now we're just going to change the name in our code. So when it has finished deploying, we're going to just go in and edit the source code real quick. And we'll just wait for it to deploy. We're going to change the source code so that the table ID is ERC20 transfers instead. Then we can activate our webhook from Moralis. Okay, there it is. Now we can go into source and click edit, and we're going to just change this to ERC20 transfers instead for the name. Whatever you inputted here as the table name. Go ahead and save and redeploy. And then while that's going on, we can copy this URL here. Oops. Copy that URL to the function and go to Moralis, and we're going to click past this testing, and here we're going to go to step number 7. How should we deliver the data? Select the webhook, paste the webhook in here, and then we're going to do verify webhook. First though, we need to make sure that we have permission to call this, because I think if I push this now, verify webhook, it's going to say could not post, request failed with status 403. Please check your webhook URL. So we have a permission issue. Authentication issue, because by default there are only like authenticated roles that can call this function. So that we need to solve. And let's see, where do I do this? Permissions. So you're going to go to permissions, and you're going to click grant access, and we're going to add a new principal, which is going to be all users. You can search for that there. And then we're going to assign a role, which is going to be, what's it called? Cloud function invoker. Cloud functions invoker. You want to save that. And this will open up public access to this function, which of course comes with its own risk. You need to be aware of that. And we're going to make sure and implement a mechanism to make sure that we deny any request that is not coming from Moralis. I'll show you that later. And then let's also go back. I think there's one more place we have to do this actually. Let's check this cloud functions. Yeah, so in the cloud functions homepage, select it like that and then go permissions. And we're going to see if it's actually here. Cloud functions invoker all users. Okay, let's try it. Verify webhook. No, there is one more place. I need to remember where the hell it is. Okay, I found it. So we need to go to cloud run, okay? It's some other service. And here you'll find the services, the service, insert ERC20 transfers. You can select that here, permissions. And once again, we're gonna add a principal here. It's gonna be all users. And here it needs to have cloud run invoker. And then you're gonna click save. Allow public access. So basically 2 places. We need to change it in the cloud run service and in the cloud function service. Don't ask me why, but that's how I need to do it. Now it should work. So we go back to Moralis and we'll click verify webhook, response to 100 receive. If we check the log of this, now we go back to cloud functions. We should see a log. of post 200 here from Moralis. And now I can click save and deploy. This will now start to deliver webhooks to our cloud function. And this is this one, ERC20 transfers. And don't worry about these failed deliveries. That's from another project. So now I'm going to watch as these webhooks come in. So every single block now on Ethereum, as long as there's a USDT transfer, which there almost is in every single block, we will get the webhook and we will insert it into our database. And you can see now we're already getting here, inserted 25 rows, inserted 36 rows, and this is going to come now basically every 10 seconds or so. We're going to insert more and more rows, and we're going to see if it was successful. We'll go to our database, we'll query it, we'll run it. And there we go. We got all of it, including, let's see, come on, including the log index as we added. So that is everything when it comes to adding live data. Now this will continue to feed live data into your database. And if you run that for long enough time, you will have enough data to do some analysis on it, as I showed you in the beginning. But I'm also going to show you now how we're going to backfill this data from today when we started as far back as you want to, using the historical APIs that Moralis has, so that you can run really big data analysis on these ERC20 transfers. And in order to help with this syncing process, I've created this Moralis BigQuery sync script on my GitHub, which is linked in the description down below. And this is a very simple script in what it does, but I would recommend you to take some time to go through the main.js file and see how it works. But what this does is that it will, in batches, fetch a range of blocks and all of the transfers in that block, and it will insert that into BigQuery. And then it will do that for a range that you specify. And I've documented how it works quite well in this README. Basically, you input the contract address that you want to sync on which chain. You input the lowest block from where you want to start your sync. So, I mean, in theory, you could set it from block 0. It's going to take a long time, though, depending on, like, if you're syncing USDT, you go from block 0. This is going to take a long time. It's not a practical way to sync massive amounts of transfers, like USDT, for example. This is not made to sync from block 0 up until today on USDT. I'm just saying I put together this script in a few hours. In the future, though, there will be the ability through Moralis Streams to backfill all history. And maybe when you're watching this, it is available. You can check. But that's not an easy problem to solve going back to block 0. But here you can at least go back a few months without any issue. I did the calculation in terms of how quickly this can sync. In terms of, because it's going to depend a lot on which contract you try to sync. So for USDT, it's probably the most transferred token on Ethereum. So on Ethereum, USDT has about between 2,000 and 3,000 transfers every 100 blocks, which is every 150 seconds. So that's how crazy that is. And with this script, it takes about 7 hours to sync 1 month of USDT data. So if you think you want to sync, let's say 6 months, that's going to take you 6 times 7. What is that? 42 live math. So that's the kind of timeline that we're talking about here. But anyway, this script works in as you input the contract, the chain ID, you input the lowest block where you want to start your sync, and then it will sync all the way up to the oldest block in your database, BigQuery database. You can override this with this highest block override, but I wouldn't recommend it. So the way that we have it set up now is that we have our stream from Moralis that is pumping in data into our BigQuery. So we already have a block there, which is the lowest block. That's going to be the oldest block. And if we set this to null, then it's going to sync from the lowest block, let's say we put block 0, all the way up until our the oldest block in our database. We're going to get a full history. Batch size is how many blocks it will try to fetch from Moralis and push to BigQuery at once. Because if we did, one fetch, one block and then try to insert one block, it takes a long time to do that. So it's much more efficient if we can insert 100 blocks at once. This you can configure. It's going to depend on the contract that you're trying to sync. Once again, USDT is a massive contract, so within 100 blocks, you'll get like a maximum of about 3,000 transfers in most cases, and that's about the size that BigQuery can handle in terms of the sized input you can input into the SDK to upload. So if you have a contract that only has one transfer per block, let's say on average, you will be able to put this batch size at probably 3,000 blocks. And you can fetch 3,000 blocks and then insert it. And that will speed up your syncing time quite a lot. But if you're with USDT, maybe put it at 100, because the risk is that if you get some really big block in there, it will hit the limit of BigQuery and it will crash. But then you just have to restart it. BigQuery table ID, it's a table ID in BigQuery. BigQuery dataset ID is the dataset in BigQuery. We'll go through this in a second. Then Google key file path is the path to the Google key file from Google Cloud that you've downloaded, the JSON file. I'll also show you that. And then finally, this little script assumes that your database schema looks exactly like the one that I set up. So it has transaction hash, contract from to valid, all of these. You can, of course, modify this. You can clone this script and you can open it in your editor. And you, by the way, you're going to need a Moralis API key put into the env file. All of this is available in the prerequisites and the setup part here, so you can just read through that. But run npm install in the project directory, create a .env file, add your Moralis API key. I'm going to add a link here. I have forgot to do that. Create a Google Cloud service account. We'll show you that also. Download it, place it in the directory, and then you open up config.js and you configure it. So here is the, oops, a bit too much. I'll quickly walk you through main.js here and what it does. It's messy code, as I said. I put this together in a few hours. But basically, it will start off by getting the earliest block synced. So the oldest block in your database, it will get that from BigQuery. And then it will set, okay, we should fetch up until earliest block -1. And so it will figure out the range, the start block and the end block, and then the number of blocks to sync. And then it will call this fetch and insert batches. And what this will do is that it will continue to run this fetch and insert blocks with start block, end block, which takes into account this batch size of 100. It will do that until we have reached the final block. It will just continue to run this fetch and insert blocks. And that's down here. And what this will do is it will call a Moralis function to fetch all token transfers for a specific range. And then it will insert it into BigQuery. And here's where we'll have to change. If your schema in BigQuery looks different, you'll have to change that here, because these names here need to correspond to your BigQuery properties, okay? And here we also map from the values from the Moralis API to the kind of names that we have in BigQuery. And yeah, the rest is just Moralis stuff. So the fetch all token transfers uses Moralis API to fetch for a start block and end block. And then it concatenates the result and sends back. But that's really the script, that's it. So how do we set this up? Well, as I told you already, you need to go to moralis.io, get your API key and paste in here, or create the env file, .env, and set Moralis _ API _ key equal to that. Then go into config.js, and here you're going to need to put the USDT contract. If that was, maybe I left that already in there. Yeah, I did leave the USDT contract in there and the chain ID. And you have to input your table ID. We'll get that from BigQuery. So your table ID will be this name right here. So you have your project, which is this name. Then you have your, what was that, the table ID, which is ERC20, oh no, the other way around. This is the dataset ID, analysis. And then the ERC20 transfers is the BigQuery table ID, the BigQuery table ID. So you input those there, and then we also need to get our Google key file, which I have, well, I have a few of them here. I called mine now path to key file.json because I wanted to call it that here in the config. You can get that by going to Google Cloud and you type in here IAM, and then you go to service accounts, and here you have to create the service account. We'll call this import script BigQuery. Create and continue. And then inside of roles, search for BigQuery, and we're gonna add data editor, and we're gonna add BigQuery job user, access to run jobs. I think that is all we need. Let's try that. And then we'll go into our new created service account. We'll go to keys, and we're gonna add key, create new key, select JSON, create. And then you're gonna be able to download that. And you should put it into your project directory. And then we can go into, so I have mine now here, this name right here. You should copy that name, and then we can go into our config, and we're gonna select Google key path, like so, Moralis.json, that was the name I put. Finally, we're gonna see what the range we're gonna sync, what the range is that we're gonna sync. So we'll go back to BigQuery. Come on. Go into our table just to check what the lowest block is already. Query, select block number and timestamp. Make that a bit bigger for you. Select block number, timestamp from, order by, block number, ascending. So now we can see that the lowest block number, select, what's it called? Select distinct. Lowest block number we have is this 19558887, and then you can see it goes up 88, 89, 90, 91. Depending on your contract that you're listening to, you might not have transfers in every block number. This is USDT, so we have a lot of transfers. So if we want to sync, we want to have this as our ending block, which is the default. This will be the last block, or rather the block below it. So it will stop here. The script is designed to do that, but to find the start block, let's say we take this and we subtract like 500, and we'll do 500 blocks before it, and we'll see that this changes. So we'll import or add that number here, lowest block, and then we'll reduce it by, let's say, 500. So we'll put it down to 387. That's going to be the lowest block. So we'll sync 500 additional blocks before this, because the Moralis Streams is not going to do anything here. It's only adding new blocks, right? So if we want to sync up historically, we need to do that. And as you can see, my syncing script here, or sorry, my Moralis Streams has been going for quite some time. I have data back to April 1st. Yeah, today it's April 23 as I'm recording this. So this video has been taking a while to record. There's been a lot of stuff going on. We put the lowest block in as we want, we don't just copy the lowest block and paste it here. We pasted it here and then we changed it to make it 500 lower. You can do 1,000 lower, 10,000 lower, but this is just to try it. And then we put the contract. We already have my table ID and dataset ID. You'll need to fill that in. We have the key. I have the batch size set to 100. Chain ID is that. Okay. Now we should be able to run this. And you can see I've test run this in the past. We're gonna do node main.js. You can see here, earliest block synced already. It detects that from the BigQuery database. Number of blocks to sync, 499, so it wasn't 500, but 499. And then you see it starts to fetch, it logs out that it's fetching these ranges, and then it said inserted X amount of transfers in this block range. It will continue to do that, in this case, like 5 times, because we have 100 in each batch. And once that's done, we should be able to see that in our database. There we go. Let's now rerun this query, and we should see this number go down. Boom, now we're down to 387. And yeah, you can bring this down with, 1,000. Oops, 1,000, and all of a sudden you can run this again. and it will automatically now detect the new ending point 387, and it will now sync 1,000 blocks. And this can run for, well, this will take about 2 minutes probably. As I said, it takes about 7 hours to sync 1 month of data. So in this case, 1,000 blocks should be quite quick. So yeah, that's how the import script works. And as I said, I've imported quite a lot of data. I've had my stream run for quite some time. So I have almost about a month of data in my BigQuery table here. And so now the final part of this video is I'm going to show you how we can now explore this data in Looker in Google Cloud. So maybe you want to make sure that you've run this script for a few hours before you do that, so that you have some history. Let it run for a day. You'll have to monitor it though. Like I said, I spent a few hours on this script. Feel free to perfect it and make a pull request to my repo, to be honest, because maybe we could make this into something that's way better. Because once again, this can fail in the sense that maybe you get a massive block or a massive batch, and then the BigQuery SDK will not really, it will be too big for it. So then it won't, it will fail and the script will fail, and yeah, then you'll have to redo it. It is pretty good in the sense that it will not leave any empty ranges. Like it would either completely fail for a range or not. So you can see where it failed. You can always go back and then look what is the lowest block number and just restart it. Because the good thing about the script, it doesn't start to sync from the lowest block that you inputted. It actually starts, it goes in reverse order. So it starts from the highest block and goes backwards. That way you will not be left with any like range where you have some blocks synced in the beginning and then you have a massive gap to where you want it to go, if that makes sense. But yeah, so you can always restart the script in the sense that, you know, if I now, let's say, oh, now it's already, well, let's say I lower this again with 2,000 blocks and I rerun this script. And in the middle of it, let's say that there is something. Let's see, let me just insert one. There we go. Now it fails, let's say. Something happened, it failed. Okay. Then I can just, well, I could just double check it, but it won't matter. So now it's 286 is the latest one. I can just rerun the script without any modification. I already know where I want to go, right? The lowest block. And it will just recalibrate here. Lowest block already synced, 286. Okay. And it will just go about its day, continue to sync, no issues. So yeah, that is basically it. Let's now check how we can analyze this data in Looker. So if you want to start to play around in terms of analyzing your data, but here is probably where your application of this might be different than mine, but you can in Google, let's see, where do we do this? Here, you go to your actual table, you click export, explore with Looker Studio. You can also go to Sheets, for example. But here it will depend on the application. Of course, you can also do, I don't know, whatever analytics, business intelligence platform that you might have. You can connect that to BigQuery and get going. But I'm going to use the Looker Studio that's available through Google. And here we can explore our data sets. And this is now the default, and sorry for my dark mode shenanigans. There we go. This is like the default page that it draws up for me. Not particularly useful. I don't know what has here, like decimals and addresses. We will, let's see here. First of all, change the chart into a time series chart, because I'm gonna do like volume over time. We have the correct data source, the dimension, let's see, and then we have breakdown dimensions. We won't have that. First of all, the metric is going to be sum of the value, there we go, sum of value, and dimension is going to be time. Timestamp, what the hell, what happened here? Just one, please. Date range dimension, yes. Let's see, what the hell happened? We're also gonna have a filter, not a time series filter. Where can I add the filter? Okay, so it was here. I want to make sure that the symbol is equal to USDT, capital letters, because as I explained earlier, there might be other tokens in this data set. So we want to make sure that it's only USDT. Oops, did that save? Yeah, symbol filter. Okay, what's going on here? Date range auto. I'm not a looker expert, by the way. We're not going to drill down. Maybe it's that. No. So something happened when I added this dimension. Let's check date time. We're going to have date hour. Let's see if that helps. Ah, there we go. Now something. Yeah, now I have hours. We have this massive spike. Not sure what's going on there. But one problem but it shouldn't be an issue. I don't know, maybe this is an outlier or something. But what we should do is that we should make sure that we use the decimals also to display the right value, because value here will not have applied the decimals. So it will be way too big. So what we're going to do is that we're going to add a metric, add field to the formula. Yeah, we can do it here. So we'll put it as value underscore with decimals, number, display format. And we'll take this as value divided by the formula power, which is, we're going to take 10 to the power of decimals. So this is, we will divide this by 10 to the power of the decimals, which means we will remove the decimal point and remove some of the zeros or whatever you want to call it. We'll make the number smaller by, if it's 6 decimals, it will be 10 to the power of 6, which is whatever, is it 100,000, 1 million? And that will make this value into actual US dollars or actual units of the token that you're analyzing. Hey, there we go. Aggregation. Do we need to specify an aggregation? Some with decimals. Could this be correct? So every hour we have about 1 million. Let's see, what is that? No, that's 1 billion. That is 600 million. I'm not sure if that's correct, but as I said, I'm not a looker expert. We'll assume that this is correct. What is the daily volume of Tether? We gotta check. I'll put this as, just put date. Okay, there we go. So here we have about, so yesterday, April 22nd, we had 15 billion of volume. Could that be correct? Let's check CoinGecko. Oh, but this is going to be trading volume. So it might not be the same. Okay, 22 billion. So it's in the same magnitude, because this is like transfer volume. But yeah, that's probably correct then. Okay, so we'll switch back, or you can have it on a daily. You can change it from a daily to hourly, whatever you want, right? Then here, we could do, for example, what do we want here? Let's say we want to do top receivers, okay? Let's see if we can figure that out. So dimensions is going to be the 2, which is the receiver. And I think that's the only dimension. And then we're going to have sum of the value. Can I do that, please? Do I need to add the field here also? I thought that my value field from this one. Okay, so we'll add it in our actual data source then. We'll go here. We'll add the field, because it's not here, right? It's not. Okay, add a field. We'll do this again. And calculated field. Value with decimals. Formula will be, can I make this bigger for you guys? Value divided by power 10 decimals. Save. Done. Now we'll use that here. Value with decimals. Sum. And so now, let's see, maybe we need to order it too, or it will sort by descending. Yeah, so it will be correct. So it will now sum up the top receivers of ERC20 transfers. Boom, there we go. So this address apparently received 24 billion. Is a billion or trillion? I don't know, man. Yeah, that's whatever is bigger than billion, probably trillion. Yes, 24 trillion in this time period. That is a lot, but they probably sent a lot too. Maybe this is Uniswap or something, you know. So that could probably be just volume, not a individual wallet. And then you can also do things like, let's say, you want to add a chart, and we want to add like a number like this. Let's say we want total volume in the past 24 hours. Okay. Sum with decimals is correct, but date range dimension is that. To default date range custom, we're gonna add auto date range this week fixed last 7 days. Let's do it yesterday, or okay, let's do it today, whatever, 23rd. Apply. And there we go. So we have done 6 billion today so far. You can also add, you know, text. You can say here, you can say volume today. Boop. Nice. And yeah, as I showed in the beginning, there's many things that you can do, but this is how you work with this data set here in Looker. And I think that's about it. Please let me know down in the comments if you want to see more of these types of data analysis videos or import, export, bulk, working with data. And also, if you have any questions, you can leave them down in the comment section down below. You'll find all of the links for signing up to Moralis, for learning about the Streams API in the description below, along with the links to the repo for the sync script. And if you have any issues with following along in this tutorial, you can join our Discord following the link once again in the description, and you can get help from our team and from our community. I hope you enjoyed this video, and make sure that you subscribe to the channel and like the video if you enjoyed it. Thanks so much for watching. I'll see you in the next video.